This is Team 12, consisting of Carter Harsh, Jason McRae, Cliff Murphy, and Michael Wood. For our 461 Horizontal Construction Methods project, we selected the Science and Engineering Complex Phase 4.
Just for a background of our site, we selected, it's approximately 207,000 square foot complex located behind Comer. It's one of the most recent projects that the university is taking on at the moment. It consists of activities such as excavation, hauling, dumping, leveling, and drilling. And some of the equipment we monitored them using was excavators, dump truck, a rig, skid steer, and a loader. And there was approximately 24,754 cubic yards of excavated soil in a duration of 2.5 months. And obviously space was a major constraint on this site. Some of the general information we obtained from the contractor consisted of duration and excavated soil data that we obtained. And we got the durations for every task, the equipment types, and their costs associated. You see in the illustration below, we've got the original models data for cost per hour for each type of equipment.
As you can see here, this is our original model. This model consisted of two major cycles that were operating concurrently. As you can see there on top, it's excavate, piling, loading, hauling, dumping, and return cycle. And then on the bottom there's leveling, drilling, and then pushing the drilling material and piling that up. The top excavation cycle had to excavate about 1,000 cubic yards before the bottom drilling cycle could begin. This was necessary for the drill rig to be able to reach the bottom foundation. It was a 20-foot vertical drop in gradations before the drill rig could start digging the pilings. For model validation, the scheduled duration of the entire excavation and drilling cycles were compared to the model's output. As was mentioned, our nearly 25,000 cubic yards of soil had to be excavated, but this would not run completely through the model. Therefore, we shortened the model duration and to 1 day, 10 working hours, and the model was able to effectively process 2,826 cubic yards. Obviously, it is not necessary or feasible for all the equipment to be running continuously for 10 hours a day. Therefore, when you spread it out, the total excavation drug out to about 2.5 months.
As far as optimization and feasibility analysis go, the small size of our construction site was a major player and presented some challenges to changing the baseline model. However, the best case scenario would be to virtually contain an unlimited amount of excavators and dump trucks. Therefore, every time you increased by one excavator and one dump truck, your production would continuously increase. However, this isn't completely feasible due to not having enough space to have all of this equipment on site. Therefore, the best case feasible scenario was to change our original model into a direct loading model. This would consist of the excavator that was actually excavating, loading the excavated material directly into the dump truck to be hauled off to the stockpile. By doing this, we found that the direct load model implementing both 2 excavators and 2 trucks was the best feasible scenario, and this allowed us to attain a production rate of approximately 280 cubic yards an hour at a unit cost of $2.84 per cubic yard. And as can be seen in the table below are the equipment types and load capacities and some of the unit costs associated with this adjusted model. As can be seen here, this is the shortened and optimized model. If you compare back to the model that Carter previously mentioned on several slides back, we have terminated and done away with the piling aspect of the model and went straight into an excavate and load activity. We're still excavating approximately 25,000 cubic yards of material, but we're doing so with a direct excavate and load activity, and the soil flows into and haul, dump, and return. And just as mentioned before, 1,000 cubic yards of material had to be excavated before the drill rig could maneuver into the site.
Therefore, our proposed solution for maximized efficiency for this project would be the direct load model, implementing 2 hose and 2 dump trucks. As was mentioned before, with increased trucks and increased hose, production will increase and durations will be shortened, but space was a major constraint on this project. It's a small project site. Therefore, we would have to create sufficient roads for the dump trucks to be able to reach the excavation floor for direct, convenient loading from the excavator into the backs of the trucks. Also, in order to maximize production, we needed to widen the roads all the way around the site to allow for 2 dump trucks to be able to pass each other. And then another way that we decided you could maximize production was by efficient drill rig rental times. They rented the drill rig for what seemed like more time than they needed, and was left sitting around for large amounts of time. If they completely excavated one side or one basement of this complex and then rented the drill rig for 2 days while it drilled those pilings, returned the drill, and then once the second half of the project was excavated, rented the drill again, we figured that this would also help to maximize production.